Hi guys, welcome to another online lesson for National 4-5 Chemistry. Still having a look at the homologous series or family of hydrocarbons called the alkanes. This time we're going to have a look at how we draw these molecules out. So we're looking at drawing straight chain alkanes. So our learning intention for today is to be able to draw the first 8 straight chain alkanes. Okay, we're going to look at the structural formula and the molecular formula for these things. Okay, let's have a look at it. Let's dive straight in. If you haven't looked at the video on what an alkane is, then go back and have a look at naming alkanes. Do that one first. Okay, first of all, a few rules. Now remember from the last video, an alkane is a hydrocarbon, so it contains only the elements carbon and hydrogen, which makes it nice and simple because we're only dealing with 2 different elements. An alkane also only contains carbon-to-carbon bonds, and those carbon-to-carbon bonds must be single bonds. Now that won't mean much to you just now. The idea of a bond doesn't mean much to you just now. All you need to know at the minute, because bonding happens in unit 1, and we will do that later on. A bond is how different elements, essentially stick together to form compounds. Okay, now each of them is a single bond, and we represent a bond with a straight line, like that. So if I were to show a carbon-to-carbon single bond, it would be carbon, straight line, carbon, and that's our bond. Alright. Now, there are a few rules. All alkanes contain only single bonds, which means that for alkanes, you should only see single lines separating these things. You shouldn't see any double or triple lines. All carbons must have 4 bonds attached, and again in unit 1 you'll learn why that is, which means that in the alkanes each of these carbons must have 4 lines coming from it, like that. Okay, these are all the bonds, and if you count, that's bond 1, bond 2, bond 3, bond 4, and in this one there's our bond 1, 2, 3, and this one here is 4. And if you can imagine, this is where the bond actually happens, in the middle between these two. Okay, so that's how these 2 carbons are attached. Now what goes on the other 3, well, that totally depends on what it is we're talking about. Because we're talking about hydrocarbon, the chances are it's hydrogen that's going to go on most of these, because it's either going to be a carbon or a hydrogen. Hydrogens, on the other hand, can only have 1 bond. So for a hydrogen, you can only ever have 1 line coming from it. It can't have 2 or 3 or 4. Okay, now that makes it nice and simple when you're drawing alkanes, because if you have a look, there's lots of space here with only 1 line, so hydrogens could fit quite nicely around the outside. Oh, dear me, sorry about that. Hydrogens could fit quite nicely around the outside, and that would fit with all our basic rules. Okay, that's just to show you a nice quick simple explanation of those 4 or those 3 rules. It must be single bonds, they must have 4 bonds attached to a carbon, no more no less, and there must only be 1 bond attached to a hydrogen. Okay, let's have a look at our family of hydrocarbons called the alkanes then. So pause the video for a minute. You should be able to fill in the second column, the name column here, based on the number of carbons. That was covered in the last video. So take some time just now, pause the video and fill that in for me. Okay, I will And there's going to be another one with the 5, 6, 7, 8. Okay, I'm going to pause the video just now and I will fill that in as well. Okay, so as you can see, I went in and filled in what you should already have done. If something's got one carbon, then we know, or hopefully should know now, that its name is methane if it's an alkane. Meth is the first part of the name. Because it's got one carbon, we know it's meth. And the surname, because it's an alkane, they all end in ane. Okay, and the same for ethane, eth because there's two carbons, and ane because it's an alkane. Okay, and all the way down, propane, butane, pentane, hexane, heptane, and octane. Okay, if you don't know that, go back to the video which is naming straight chain alkanes. Okay, right, let's get down to the business of drawing these. So we need to be able to draw something called a full structural formula. A full structural formula tells us how, not only what elements are in a compound, but how they're arranged. So we know that because it's a hydrocarbon, we know that we're only going to be dealing with carbon and hydrogen. We know because it's methane that there's only going to be one carbon. We know that carbon needs to have 4 bonds attached. That was one of our rules. We know that that's sort of the only carbon there is in this because it's only got one carbon because it's methane. Which means that these other bonds have to be filled in with something. The only thing that it can be filled in with is because it's a hydrocarbon, it's hydrogen. Hydrogen is the only other thing that can be allowed in a hydrocarbon. And so what we've got is we've got a full structural formula for methane of a central carbon, 4 bonds around that carbon, and hydrogens filled in. Okay. Now, if we have a look at the last column, the molecular formula, that doesn't tell us how things are arranged or in space, or how many bonds there are in it, but what it does tell us is how many of each type of element there are. So what we can see is that there is one carbon, so we leave the C as it is. We have 1, 2, 3, we have 4 hydrogens, so what we do is we put a little subscript 4 down here. And what that tells us that there is one carbon and there are 4 hydrogens. Let's have a go. I'll do ethane as well, and then I'll let you have a go at the others. So ethane, we know ethane because it's eth has 2 carbons. So let's put that in. Carbon, carbon. We know it's an alkane, which means that the carbons have to have one single bond between them. And we know that all the carbons need to have 4 bonds, no more or no less. So let's put those in. We do what we know. Now that we've filled up the carbons, the only thing left to put in is the hydrogens. We don't know how many there are, but all we do is make sure that we fill in all the rest with hydrogens, and we're going to be absolutely fine. Now you'll see that we've met our rules. Each carbon has 4 bonds, 1, 2, 3, 4, and each hydrogen only has 1 bond. Now let's look at the molecular formula. How many carbons do we have now? Well, we have 1, 2, so we can put a small 2 down the bottom. And how many hydrogens? Well, let's count them. 1, 2, 3, 4, 5, 6. So we put a small 6 down the bottom here. Okay, I want you to have a go at propane and butane on your own and see how we get on. If you get that done, go ahead and do the other 4. I'll fill them in and then we can come back and talk about it. Pause the video just now and have a go at that. Okay guys, so hopefully we are back to completing that. So let's have a look and see, make sure that what you've done is the same as what I've done. You can see that each carbon has got 4 bonds round about it, and where there isn't a carbon-carbon bond, there's a carbon-hydrogen bond. Make sure, a couple of things, make sure that all your bonds are actually going to atoms. So for example, it wouldn't be correct if you had, for example, it sitting like that. I know that you mean to put that there, but if it's sitting floating on its own, it's no good. You see that all my bonds are going to a particular atom. Okay, you need to make sure of that. Now, I want you to have a quick look just now at all of these, and in particular focus on the molecular formulas. I want you to be having a look to see, can you spot a pattern in these molecular formulas, particularly pattern between the number of carbons and the number of hydrogens. Have a little think about that, pause the video, we'll go on and talk about that just now. Hopefully you spotted a pattern. The pattern that you should have seen is that to work out the number of hydrogens, all you need to do is take the number of carbons that the alkane has, double that, and add 2. I'll go back and show you. So if we take pentane, for example, if we have a look at pentane, it's 5 carbons. If we double 5, we get 10, and then add 2, 10 plus 2 is 12, and we end up with 12 hydrogens. If we take another one, just as an example, hexane, we've got 6. 6 doubled is 12, add 2 is 14. 7 doubled is 14, add 2 is 16. So it works for every single one. So this is what this is telling us. N is our number of carbons, and H is our number of carbons times 2, doubled, add 2. So it doesn't matter whether your hydrocarbon has 1 carbon, or your alkane has 1 carbon, or it has 100 carbons or 1,000 carbons. You will be able to work out how many hydrogens it is without drawing it out. Okay, all you need to do is double that number and add 2. So if you had a hydrocarbon with 100 carbons, and that hydrocarbon was an alkane, that 100 carbons, if you double it, that's 200, add 2, that's 202. So the correct for a C100, the correct molecular formula would be H2O2. That's called a general formula because that can apply to all alkanes. As long as it's an alkane, then that's going to work. Okay? Excellent. So hopefully that makes sense. If it doesn't, go back and have a look at the video. You can have a chat to me online. Have a little go at some of these questions. So let's flip it away there. I'll move it back. Have a go at some of these questions. And pause the video, have a go. I'll go over them just now. Okay, what is the general formula for the alkanes? Well, hopefully you remember, we've just covered that. The general formula is CnH2n plus 2. In other words, double the number of carbons and add 2 to get the number of hydrogens. What is the molecular formula for an alkane with 12 carbons? Well, we can use the general formula to work that out. We don't know, we've never drawn it, but we should be able to work out. So if we've got 12 carbons, then we need C12. If we use this general formula, we know that if we double the number of carbons and add 2, we'll get the number of hydrogens. So if we double 12, we should know that we get 24, add 2 is 26, and that would be the correct answer. Okay, draw the alkane with 12 carbons and check your answer to question 2. So I'll pause the video while I do that so you don't have to see me drawing all that out. Okay, there it is guys. So you you can count the number of carbons just to make sure that I've written out 12, and then go ahead and count the number of hydrogens, and you'll find that the number of hydrogens that are on that molecule is 26. Okay, if you're stuck at any point, go back and have a look at the video, have a chat with me, then go on and have a look at the class notebook and see what the next task is. Okay guys, thanks very much. See you later, bye.